දේශය ලොව ලොබ බැඳුණු දේශය මගේ මේ රටයි සුන්දර බලනු මැනසකි ඉරක් පායනා දේශය ලොව ලොබ බැඳුණු දේශය මගේ මේ රටයි සුන්දර බලනු මැනසකි
Lord Buddha visited Sri Lanka several times. However, Mahiyangana has become as the first holy city in this country because Lord Buddha visited it first with the invitation of Sumana Samandevi. The major income of the people living in these areas is received from agriculture. These people are busy especially at the planting period and harvesting period, which limits to maximum of 2 months period, leaving a period of at least 2 months in between. The farmers are mostly idle during this period. In new generations, people are more educated and has vast knowledge and skills related to self-employment opportunities. To enhance and promote self-employment opportunities, one of the major infrastructure facilities they needed is reliable and good quality electricity supply in their area. Construction of 63 MVA grid substation with 6 distribution feeders and 2 generator feeders at Mahiyangana is one of the top priority infrastructure project launched by the Transmission Project's branch of Ceylon Electricity Board. The project is managed by the project manager and his staff of the Office of Augmentation of Grid Substations and Renewable Energy, projects under the supervision guidance of Deputy General Manager, Transmission Projects, an additional General Manager, projects of Ceylon Electricity Board. The construction work is handled by the consortium of LTL Projects, Private Limited and Mitsubishi Corporation Japan on turnkey basis. This project was funded by Asian Development Bank and the loan is granted through. The total project cost for this substation is Sri Lankan rupees 178,921,960.49 and USD 3,666,060.58. The project land is situated at Dahigala, facing Dambarawa River. The land area is around 5 acres and surrounded east by Dambarawa River Road, south and west by the land belongs to Ceylon Broadcasting Corporation and north. The project is commenced in November 2010 and completed in November 2013. It took a significant time for land preparation because the original land consisted of a steep slope from west to east and a huge rock in the middle of the land. The land was finally prepared for 2 steps. Top step is used to build the control building and generator room and watch huts. The lower step is fully used to build the switchyard. bottom casting equipment foundations at switchyard was critically delayed. However, construction of equipment foundation was completed within a very short period of time to the expected quality and strength as a result of proper planning and cooperation between CEB and contractor staff and workers. Load 132, 33 kV, 31.5 MVA power transformers. Usually these are the most expensive equipment in the substation and are imported from a reputed transformer manufacturer called PALS, Indonesia. All the 132 kV and 33 kV disconnectors are purchased from a well-known manufacturer Coelm, Italy. All 132 kV circuit breakers are purchased from ABB, Sweden. All instrument transformers such as 132 kV and 33 kV current transformers, voltage transformers and 33 kV circuit breakers are from Crompton Greaves Limited, India. Auxiliary and earthing transformers are purchased from Lanka Transformers Limited, Angalana, Sri Lanka. All equipments and steel structures are properly earthed through underground earth mesh provided. Also, overhead lightning shield wires are provided to protect outdoor equipment from external lightning strikes. Switchyard premises is lighted up by providing flood and street lights, which are automatically controlled through photo cells. A single-story control building is constructed with all control facilities and other facilities to operators who are on duty. The total floor area of the building is 2,000 square feet. The entire building is fully air-conditioned except the battery room and storeroom and restroom. However, the restroom is ventilated through fans. Exhaust fans are provided for battery room, storeroom and toilets. Building floor is tiled except battery room and storeroom. Raised floor tiles are laid in control, protection panel room, auxiliary room and operator room. rod system is introduced to protect entire control building from lightning strikes. Fire detection system is commissioned inside the building and connected to substation automation system to give a common alarm to the operator. Fire panel was fixed in front of the operator's desk so that the operator can attend the panel quickly and find the fire zone. Portable fire extinguishers are provided at many reachable locations for easy use if a fire occurs at any location within the building. Fire doors are fixed at locations where necessary. Exit signboards with backup power are also hanged at many locations to show easy evacuation routes. Auxiliary supply to the substation is taken from one of the two auxiliary transformers installed at switchyard at a time, and standby supply is taken from the standby diesel generator installed at car park. However, automatic emergency DC lighting system is also provided with limited lighting points inside the building to operate when none of the auxiliary supply systems are operative, including standby diesel generator. This substation has storage battery systems in both 110-volt DC and 48-volt DC. The 110-volt DC system is used for switchgear tripping and closing duties, alarm and indications, and emergency lighting. The rating is higher than 200 ampere hours. Powering up of communication and SCADA equipment is done by 48-volt DC system and has the capacity of 100 ampere hours. Control and protection functions for all equipment are provided through GE relays manufactured in Canada. Such relays are wired and assembled in control and relay panels manufactured by GE India. The substation system is designed according to IEC 61850 protocols. This system comprises full station control, monitoring and communication functions. It has a communication gateway to National Control Center. Substation automation system, dual, consists main operator station and engineering workstation. One of the station computer shall operate the system in the online state while the other acts as standby. The standby computer continuously updates and shall take over the SA system duties when main operator station fails. The system is capable for including future extensions too. This substation is proposed to energize through newly constructed 21 km long, 132 kV double-circuit transmission line from Rantembe substation to this substation. Construction work of this transmission line was started in January 2010. The total estimated cost for construction of this line is Rs. 525 million, funded by Government of Sri Lanka. The line was constructed by the staff of Mahi GSS Project, branch under DGM, Transmission Projects of Ceylon Electricity Board. The line starts from Rantembe substation, crosses both Central Province and Nuva provinces and ends at Mahiyangana Gss substation. A part of the line around 2.6 kilometers traverses Rantembe hilly area and the balance runs through paddy fields and crosses the Mahaweli River. The line route was surveyed using CED-owned equipment and CED staff. Line profile design and tower spotting were also done by CED staff. required instructions and guidance during erection were provided by the staff of CEP. This line has 67 towers, including 2 terminal towers at Mahiyangana Gss Station and Rantembe stations. The line has 19 angle towers out of those 67 towers. Terminal tower at Mahiyangana Gss Station is TDT type, and that at Rantembe Gss is TDT plus 06. TD1, TD3 and TD6 towers are also in the design, in addition to TDL towers. Soil investigation tests were carried out for all the tower locations. Accordingly, foundation types are selected. One of the difficult tasks we encountered at the beginning is marking for way leaves in the wildlife area. Our officers and other staff finished this event at the beginning very quickly with whatever the difficulty they met in the jungle. Way leaves are removed by 3 separate parties. Trees in government lands with economic value by state timber cooperation. Trees in private lands with economic value by landowners. Compensations are paid to tree owners by CEP. Trees in private lands and government lands but no economic values and reluctant to get removed through owners are removed by stringing contractor. For such removals, contractor was paid by CEP. Construction work of the line was mainly carried out in different phases, such as construction of foundations, tower erection and stringing of conductors and earth wires. In the meantime, materials were procured through separate tenders such as tower stubs, tower materials, insulators, hardware and accessories, conductors and earth wires, OPGW and accessories, etc. Tenders are also invited for foundation erection of towers and stringing of conductors. Tower stubs and conductors were procured in Sri Lanka and tower materials and earth wires were imported from India. Towers were tested in presence of CEP inspectors. OPGW and insulators, hardware and accessories were imported from China. The total material procurement cost is ₹254. Construction and tower foundations were done through 3 separate contracts. From Rantembe to Ambagahapalesa by Balance Engineering Company, Ambagahapalesa to Moraya by Engineering Laboratory Services Private Limited, and Moraya to Mahiyangana Gss by Lanka Creative Private Limited. As scheduled, it took 7 months' time to complete tower foundations between Ambagahapalesa and Mahiyangana Gss Station. However, in between Ambagahapalesa and Rantembe Gss Station, it took almost 1 year time to complete tower foundations due to unexpected time consumption for retaining wall construction at few tower locations and head carrying involvement in the hilly area. The total foundation construction cost is ₹109 million. tower erection was done through 3 separate contracts. The 2 contracts, from Mahiyangana Gss Station to Mahiyangana are done by Lanka Creative Company Private Limited, and from Mahiyangana to Rantembe Gss Station is done by Balance Engineering Private Limited, except the 3 closest towers to Rantembe Gss Station that are erected by Transmission Construction Branch. Unexpectedly auxiliary cross-arm of the terminal tower and to modify to suit the tower and entry locations, and that was done by the staff of Transmission Construction Branch. Again, the tower erection work is delayed unexpectedly due to the same reasons as in the construction of foundations, and completed in December 2012. The total cost of tower erection is rupees 17 millions. Stringing tools including tensioners and pullers are hired from DGM, Transmission Construction Branch, and DGM O&Ms Branch, and final total hiring cost was rupees 11 millions. Stringing of conductors in this line started in January and ended up in May 2013. Stringing of conductors and earth wires in the entire line was done through 2 separate contracts. However, both contracts were done by joint venture of George Stewart's Private Limited and Maverick Engineering Private Limited, Sri Lanka, to the total cost of rupees 48 millions. Required instructions and guidance during conductor stringing were provided by the staff of CEP. During line construction works at different stages, crops and people are damaged and they are compensated by CEP. Finally, compensation to the lands where towers are occupied are also paid to landowners by CEP. The total actual construction cost of this 21 kilometers long transmission line is rupees 430 millions, which is less than the estimated cost, which is rupees 525 millions. The actual per kilometer cost is worked out to be rupees 21 million. However, current day cost of construction of similar transmission line on turnkey basis is around rupees 15 millions, which is considerably higher when compared to this cost. This is an incredible achievement of all of us, starting from project manager to unskilled laborers who engaged in construction of this line, from CEP side as well as contractors side, due to their heartiest effort to make this task success.